All right, let's do some preliminary checks on this thing. The self-test is bad. The self-tests seem to pass ROM and RAM, so I think the digital circuitry is okay. The error code was 202, which points to the A2 assembly, which right now is on the other side. But let's go ahead and just, as a general principle, whenever I work on stuff, let's just check if we can find some voltage rails. HP's Agilent, in this case, is usually pretty good at looking at putting those things on PC boards. So let's see, let me move you guys. All right, I see some test points back here. -10, +18, +5, -18. Yeah, so we could check those. And I think that's one big board. So this is one big giant board. So those are all the voltages on this board. So let's go ahead and check those. Where is ground? Sometimes ground is hard to find as a test point on these things. Now, one of the problems with this board is there's a whole bunch of floating ground, so you have to make sure you pick the correct ground. There's a trace here. This looks like a ground. Let's go ahead and use that as a ground. And I'll put this over here on the minus, what's it say? It says -10. Bring this over here. Is that in camera? Yeah, that's in camera. All right, let's put a power cord on this thing. Where's the, there it is. It's this direction. Okay, let's turn it on. And I get 0 volts. Oh, wait a minute. This is probably not ground. How about this? Is that ground? Let's see here. Oh, we're in AC volts. That's silliness. Let's see here. Okay, there's DC volts. Let's go back to that test point again. -26. How about this? -10. So this is a good ground here. We can clip on, yeah, right there. So -9.88. Okay, fine. This must be +18. Okay, +18. -18 and +5. Now, another thing to do is to go look with an oscilloscope to see any ripple, but with this particular meter, I should turn the lights. Can you turn? Oops, that's not what I wanted to hit. Let's see here. Let's see, let's turn the light on so you can see it. And then we'll hit dual. And dual again. Let's see here. There we go. We've got DC volts here and we've got AC volts here. So we have 0.01, 0.03 volts AC. So no ripple on that one. -18, 0.02, +18, 0.06, 0.04, -10, 0.02. Yeah, so there's no ripple on the supply. So at least this board has good power going to it. And we'll do a visual to see if we can see anything burnt. And then we'll do a thermal camera. I have the luxury of doing a thermal camera on things. Let's see if something looks out of whack. All right. Something's getting warm over here, and it's getting up to 50. So this is the high precision 7-volt reference. Under that little insulator there is the fancy chip, and the output of this is to generate +7 very accurately, and it has an oven. So this big transistor here is getting hot, but it's the one supplying current to warm this thing up. So that seems just fine. All right, what's going on over here? Something seems pretty warm over here. Yeah, plus 36. Yeah, these diodes here, CR, the CR seem to be getting a little toasty. Wonder what that's all about. Let's see. So we have, we'll just remember that these are guys, they're probably Zener diodes, that'd be my guess. They're just getting a little warm, but they're fine. That looks fine. Some of these things are get warm because they're kind of high speed. Got something a little warm over here. Let's see. Down near this side here now, and looks as though that guy there is a bit warm. 34081. He's running at about 40 C. Not bad. It just seems a little unusual. We'll probably just have some fast circuits from the old days. They just run hot. This guy here is also running a little warm. That guy's running a little warm. It's probably just standard stuff. And probably just fine. This one down here is running warm. All right. Okay, but I don't see anything too crazy on this side. Let's flip it over. Oh, okay. So let's rearrange you guys a little bit. All right, this is the A2 assembly. This is the board that supposedly is bad in this instrument. And normally we'd just do a board swap, right? Send it in the factory, they do a board swap. But we don't have that luxury. So let's see if I can find some things here. Yeah, let's go in over here. And from reading stuff online, that is a trouble area. Let's see if I can find the schematic for that trouble area. Oh, it's in the big one. It's in the big schematic, which I printed out, big size. All right. It is right over here. Let's move you guys. All right. Plus 18 comes into the circuit. There's an LM 15, it's a 7815 and a 7915. So it generates plus 15 volts and minus 15 volts from the 18 volt rails. And then it sends them through two fuses into this transistor. And that transistor is there to provide, I'm assuming it's to provide a soft start. Or a capacitive multiplier. It might be a capacitive multiplier. Anyway, it's a 15 microfarad capacitors on the bases, and that gets multiplied by VBE that goes out. There's a plus 15 on the outputs too. But it does start up slow as well, so it does kind of two things. It starts up slow, and it acts as a capacitive multiplier. We have a plus 14 and a minus 17. Interesting. Oh, yeah, see this circuit takes the 15 and stiffens it up. This one generates the 15 all by, minus 15 all by itself, but it also takes the minus 18 and stiffens that up into a minus 17. So we can measure the plus 15, the minus 15, well, all of these, measure all of these voltages. So that's what we will do. And they all live off camera here. Just a second. All right, they all live right here. These are the two fuses. These are the two transistors. Let's go ahead and turn this on. Let's get some, so I'm going to assume that's ground. Let's go ahead and measure the voltage here. There's a plus 14. Okay, so we want to measure the, let's see, where is the two regulators? I don't see the two, the U701. Where's U701? That's the 78. Yeah, it's way over here. So here's the input. I gotta zoom you guys back up. Okay. So here are the 3-terminal regulators. So we can measure a bunch of voltages over here. We have a 14.6, a minus 15. Why did that beep? Oh, I don't know why it beeped. 18. Okay, so we get plus and minus 18 on the inputs. And then those, so that's all working. It's going to come over here. So let's take a look at the two fuses. We have 14 on that one. And on this one we have minus 18 and minus 18. Okay, so the fuses are working. The 70, let's see, the fuses should have 15 volts on them though. Should have 15 and minus 18. And they have, oops, they have 14.6, okay, and then they have minus 18. Okay, so those are good. And then the output of the transistors give us 14 and minus 17. And they go into another, okay, there should be more capacitors than I see. Let's see, this is, I can't read upside down. This is Q702. That one should give us minus 17 on the emitter, which should be this one. We have minus 17.6, that's good. All right, so that one's working. And then on this side, we should get the minus 14. Then we get 13.8 and 14.5, 14.5. Okay, well, those both work. So power seems to be good everywhere. But still no go. All right, let's do a thermal check. All right, I got toasties over here, 51. That guy there is some type of fast op amp. He's getting a little toasty. And that guy's there's 51. He's getting a little toasty. What is he? Oh, he's one of those. Okay, so this instrument has a notorious habit of burning up comparators. or I should say it's not the instrument's fault, it's the actual part's fault. The parts just fail after a decade or two. And this is one of those parts. It is a, get out a magnifier. It is a EL 2018, EL 2018. If anybody has a bunch of those laying around, let me know, because I could use them. I'm assuming I'm going to have some dead in this thing. EL 2018. Now the problem with that op amp is it's no longer made, and worse than that, there's no modern equivalent, because it can do plus or minus 18 volt rails, and it can input plus or minus 40 volt signals. And this one is running 53 degrees, which isn't too bad. So that one's probably fine. But let's look on this board. And here's something that's toasty. 44, that's not bad. What's he? He's another one of those EL 2018s, so maybe he's just okay. Boy, that guy's toasty. Who's he? Oh, he's that voltage regulator. He's the 701. The 701 is the 18 volt to 15 volt converter. That's why he's getting warm. I got one resistor over here that's kind of warm, 44. That's just a dropping resistor on this circuit, but oh, wait a minute. Something's hot down over here. 65. Woo! That's toasty. Yeah, this guy down there is getting toasty. 65. I don't think that's normal. I don't think that's a normal chip for an instrument like this. 65C. We'll keep an eye on him. 65, what is he? Oh, he's an HP part number. He is an 1826 dash. 1826 means it's an analog part, and it's a dash 1808. So we'll have to get a converter. I have some charts that converts these numbers, and the manual might convert them as well. I'll have to check the manual, but yeah, that guy, 66 degrees C, that doesn't seem too good. Which one is he? He is U504. Okay. We need to take the top off too. Take a look inside. But U504. Let's take a look at what he does. .504, 502 is here. 504, that's 404. Let's see. Here are some fives. Let me get out my magnifying glass. Where did it go? Okay, this is U504 here. He's an LM6321 buffer. Now buffers do get hot. He's got a minus 15 supply. And he's got 4 pins for the supply, so he's obviously minus supply is heat sink. What does that mean? Minus supply is heat sink. That part doesn't have his heat sink. That's interesting. Maybe they added a heat sink later. Huh. Because they were blowing those guys up. That's interesting. What's the date on the schematic? 89. That should be pretty close to my unit. Okay, so that guy is suspicious. We could look at pins 2 and 7. It's just a buffer. pins 2 and 7. Okay. Let's do that. Pin 2. Pin 2 is minus 15, and pin 7 is minus 14. A little bit of a voltage drop on a buffer, huh? Interesting. What are the supplies here? Supplies minus 15 as predicted. Huh, I don't know. He looks toasty to me, so he's suspicious. Let's see, if he didn't work, overload detection and level trigger. I don't think that explains why my device is bad. Possibly. There's some jumpers over here. Overload jumpers. Interesting. Huh. Oh yeah, they're down there. I don't know. I don't see anything off the hand immediately other than one hot component, which may or may not be good or bad. All the voltages are good. The only other thing I'll say is when I looked at this earlier, these fiber optics, so these are plastic fiber optics, okay? And so they're super low cost, and they're used as a long distance communication where you want to isolate grounds. And this one is fairly loose. Okay, that one's fairly loose, and this one is fairly loose. If you, yeah, I don't like the way these feel. If you go over to another one like over here, and you feel those are nice and tight. Yeah, these are nice and tight. And these are super loose. So I'm kind of curious why these are loose and what it could do. Let's go ahead and just leave that one open for now, and let's do a test. Self-test failed. Okay. Where's my error button? Oops. Let's see. Error. Still get a 202 even with that unplugged. Let me unplug this one as well and see what happens when I do my self-test. Error. 202. I guess it doesn't really tell me unless if they weren't plugged in the first place. Yeah, this one is just super loose. I don't know why that plastic would have gone bad like that. It might just be aging. Everything might be fine. Yeah. That doesn't help a bit. And it doesn't point to this board either. So I think what we need to do is learn the schematics, memorize the schematics, try to figure out the flow of everything, try to get some theory of how to troubleshoot this thing. There is no troubleshooting guide in the manuals. There is a clip, which is the component level master document for the device, so I do have schematics, and there's an assembly level troubleshooting guide which says replace this board. Okay, so let's keep digging.